discussed some numericals, and those numericals I gave you as your homework. Today we'll be first discussing the problems that you have regarding your homework part, and then we'll be moving to the next set of questions. So again, today in this class, we'll again be doing the numerical part, since the numericals are very important from this chapter from the point of view of board examination. So we'll be concentrating on numericals. I'll be question number 6 dekhte hain kya hai. So question number 6 says the iron door of a building is 3 meters broad. 3 meters broad ka matlab ho gaya that the width of the door is 3 meters. Okay. So let's say this is the door, then this width is 3 meters. Let's say it is hinged at this point, right? So it can be opened by a force of 100 Newton normally at the middle of the door. So if we apply the force at the center point of the door, then we need the force to be 100 Newton, right? यहाँ पे Newton का n गायब है, n होना चाहिए 100 Newton. Now they are asking us to calculate the torque needed to open the door. So now we have to find the torque needed to open the door. Now what is the formula for torque? So the formula for torque is force into the perpendicular distance between the point of application of force and the pivot point. So this is the pivot point. यहाँ पे hinges हैं door के, right? Now in the question it says that it can be opened by a force of 100 Newton at the middle of the door. Now this is the basic thing that you have to look into the question. This is the the point where most of the students would ignore this, and then the answer would become wrong. Middle of the door they are asking. They are not asking that at the other end of the door. So if the door is 3 meters wide, the midpoint would be at 1.5 meters. Yes or no? Yes or no? Total 3 meters अगर चौड़ा है तो 1.5 मीटर जो मिड पॉइंट होगा that would be at around 1.5 meters. Right or wrong? Yes. Is this clear to everyone? Yes. Great. Okay. So that means force given is 100 newtons. Great. And the distance given is 3 meters. 3 meters ka midpoint would be 1.5 meters. So multiplied by 1.5. So this will be 150 Newton meter. Is this clear to you? Yes or no? Right. So let's move to the next part now. The second part. The second part says the least force and its point of application to open the door. Now they are asking us ki if we open the door with the minimum force, then what should be the least force? First part. And the second part, in the second part itself is the point of application. कहां से push करें इस door को ताकि हमको minimum force लगानी पड़े. Is this clear? So this is the question. Now since we know that torque produced is equals to the force into the perpendicular distance, right? Now if we want to increase the torque and we want to decrease the force, then what do we have to increase? The perpendicular distance. भाई अगर force हमको same रखनी है और torque बढ़ा देना है तो बढ़ाने के लिए क्या करना पड़ेगा? हमको जो distance है perpendicular distance उसको जितना ज्यादा करेंगे, if you increase perpendicular distance your torque will also increase. So in order to use the minimum force we have to increase the distance, right? अच्छा, so maximum distance हम कहां पे apply कर सकते हैं force को? So the maximum distance could be, since the door is 3 meters wide, so अगर हम लोग बिल्कुल door के edge पे push करेंगे, at this point if we push the door, then the distance would become 3 meters, right? Okay, so that means the torque is same for opening the door. So torque is what? 150 Newton meter. Force, we have to find the minimum force. So let's say the minimum force is F, and now the distance would be 3 meters. Yes or no? मिनिमम फोर्स निकालने के लिए हमने क्या किया? हमको नहीं पता मिनिमम फोर्स कितनी, हमने इसको F ले लिया. जो मैक्सिमम डिस्टेंस था, ये मैक्सिमम डिस्टेंस पे अगर हम लोग फोर्स लगाएंगे तो मिनिमम फोर्स लगानी पड़ेगी. तो मैक्सिमम डिस्टेंस कितना हो सकता है? 3 मीटर. सो 3 मीटर्स ले लिया. नाउ वी कैन फाइंड द फोर्स. सो फोर्स विल बी इक्वल टू 150 डिवाइडेड बाय 3, दैट इज इक्वल्स टू 50 न्यूटन विद यूनिट. सो दिस इज द फाइनल आंसर. इज दिस क्लियर टू ईच एंड एवरी वन ऑफ यू? यस और नो? चलिए, लेट्स मूव फॉरवर्ड. लेट्स मूव टू द नेक्स्ट क्वेश्चन नाउ. सो दिस इज द फाइनल आंसर. Right. So ये वाले question, these questions are now again very important from the point of view of board examination. So here the question says figure represents a meter. Okay, the basic principle behind this is, let's say this is a seesaw. Seesaw झूला है ना सबने बचपन में, वो जो बचपन में ऐसे बैठ जाते थे एक तरफ से दूसरे को ऊपर कर लेते थे. Seesaw, everyone has experienced seesaw? Yes, the swing seesaw वाला झूला सबने experience किया है, जिसमें एक तरफ बैठ के दूसरे को कहते थे अब उठा के दिखाओ. Yes, तो वो वाला जो झूला होता है सीसॉ वाला झूला, सीसॉ वाला झूला इज दिस. लेट्स से देयर आर टू चिल्ड्रन. Okay, so let's say this is Mayank and this is Pratha. So two students of our class. Okay, now, so if I say Mayank is heavier than Pratha, then in this case, let's say this point is A, this point is B. So अगर Mayank heavier है Pratha से, तो seesaw किस तरफ को झुकेगा? Which point? Okay. Now, if I say that Pratha is, the weight of Pratha is equals to the weight of Mayank. Now what Pratha is doing is, Pratha is shifting herself towards the center, towards the fulcrum, towards the center point. Pratha जहां पे बैठी थी उससे थोड़ा सा आगे खिसक के यहां पे बैठ गई, यहां पे आ गई अभी Pratha. So Pratha is now standing over here. Now if their weights are same, both have same weights, Pratha has shifted towards the center point. Now tell me at which position, which part the swing will tilt to, point A or point B, or will it remain the same? So this is a very good question. Now अगर आपने बचपन में झूला होता तो आप सही आंसर बताते. आपने बचपन में ये झूला नहीं झूला है इसलिए आप गलत आंसर बता रहे हैं. As you move towards the center, जब आप सेंटर की तरफ बढ़ेंगे ना, तो उस केस में this swing, this seesaw will tilt towards point A. Mayank will become heavier than Pratha as Pratha moves towards the center. Now, the basic idea is, how come Mayank has become heavier than Pratha when weight of both of them were equal? अगर मयंक यहां से नीचे आ गया, इसका मतलब मयंक मोटा हो गया. प्रथा आगे आई, मयंक मोटा हो गया. फिर प्रथा और आगे आई, मयंक और मोटा हो गया. ऐसा हो सकता है क्या? प्रथा के आगे बढ़ने से मयंक मोटा होता जा रहा है. फिर ऐसे तो जो स्लिमिंग वाले जिम है वो बंद हो जाने चाहिए. एक आदमी को सीसॉ पे बिठाओ, उसको पीछे करते रहो, पतले हो जाओगे बिल्कुल बॉडी. ओके, नाउ सी. सो प्रिंसिपल ऑफ मोमेंट, जिसको हम लोग शॉर्ट फॉर्म में क्या कहते हैं? पॉम. क्या कहते हैं? पॉम. ठीक है, थोड़ा सा ऐसा pom word है, but pom is principle of moment. So whenever I'll be writing pom, that means principle of moment, right? Now principle of moment क्या होता है ये समझते हैं. So principle of moment says that if any object is balanced at the center, ठीक है, this object is in equilibrium. Equilibrium का मतलब है this will not tilt in any direction, it will remain straight, right? So if any object which is kept on a pointed item, or we say if it is pivoted at some point at the center, then this item will remain in the state of equilibrium. Equilibrium का मतलब हो गया neither it will tilt in this direction nor it will tilt in the other direction. Right? If this is in equilibrium, then in this case, the torque applied in the anti-clockwise direction will be equal to the torque applied in the clockwise direction. Now, torque के दो नाम होते हैं, moment of force बोल सकते हैं, torque बोल सकते हैं, turning effect of force बोल सकते हैं. All three are same, right? So if we say torque is equal, that means moment of force is equal. That means the turning effect of force will also be equal. All three are same, synonymous, right? So कुछ भी बोले, that means clockwise moment will be equal to the anti-clockwise moment. So in order to be in the state of equilibrium for any object xyz, the clockwise moment should be equal to the anti-clockwise moment. So at equilibrium, the clockwise moment will be equal to the anti-clockwise moment. So this is very important. This is the basic principle. This is the basic idea on which these types of numericals are based, right? So in this case, the clockwise moment will be equal to the anti-clockwise moment. In the last class, I explained you which one is to be taken as positive and which one is to be taken as negative. Clockwise moment is taken to be negative, whereas anti-clockwise moment is taken to be positive. समझाया कैसे था? याद करने का क्या तरीका बताया था? जुगाड़ is that in clockwise moment, C से होता है चाची, ठीक है, A से होता है आंटी. बोथ ऑफ देम आर सेम. चाची बोलो या आंटी बोलो. आंटी इज सोफिस्टिकेटेड, चाची इज बिलो मिडिल क्लास, राइट? हिंदी वाला चाची है चाची. आंटी बोलो तो लगता है कि वह फॉरेन से आए, कनाडा वनाडा से आए, राइट? सो आंटी गिव्स अ पॉजिटिव फीलिंग, चाची गिव्स अ नेगेटिव फीलिंग. सो सी इज नेगेटिव एंड ए इज पॉजिटिव. ठीक है? सो क्लॉकवाइज इट इज नेगेटिव एंड एंटी क्लॉकवाइज इट इज टेकन एज पॉजिटिव, राइट? Okay, fine. Great. So these questions now, let's come back to the same problem. So while Pratha was moving towards the center, Mayank became heavier. Now what is the reason behind this? See, now we were talking about torque. Torque is equals to what? Force into the perpendicular displacement, right? Now जितना वेट ये अप्लाई कर रहा है, दिस इज इक्वल्स टू बेसिकली फोर्स, राइट? जो हमारा वेट होता है वो क्या होता है? फोर्स ही तो होता है. जिस फोर्स से ग्रेविटेशन अर्थ इज अट्रैक्टिंग द ऑब्जेक्ट टुवर्ड्स इटसेल्फ, राइट? सो एफ इंटू डी इज इक्वल्स टू, अब लेट्स से the weight of Mayank is F1 and weight of Pratha is also equals to F1 because their weight were same. Now the distance of Mayank from the center is, say, let's say D1, and the distance of Pratha from the center when she was sitting at the end was, let's say, D2. So in this case, the anti-clockwise moment will be equal to F1 into D1 and the clockwise moment created by Pratha would be equal to F1 into D2, right? Now, if I say that both of them were at the, initially, both of them were at the state of equilibrium. Equilibrium का मतलब है कि ये अपनी पोजीशन पे होगा, ये ना नीचे टिल्ट होगा ना आगे टिल्ट होगा, right? So it is at the point of equilibrium. In case of at the point of equilibrium, the product of F1 D1 will be equal to the product of F1 D2. Now what Pratha did is, she was acting very smart, but she was not smart. So what she did is, she moved in front, she moved a bit towards the center. तो आगे बढ़ने से क्या हुआ, जो ये D2 डिस्टेंस था ये कम हो गया, राइट? द डिस्टेंस फ्रॉम द सेंटर वुड डिक्रीज एज द डिस्टेंस डिक्रीजेस. As the distance decreases, the total product F1 into D2 will also decrease. And as a result, F1 D1 will become greater than F1 D2. Is this clear? So that means अगर हम distance कम कर देंगे, उस केस में भी क्या होगा? उस केस में भी जो anti clockwise moment है वो greater हो जाएगा with respect to the clockwise moment. And if Pratha is intelligent, let's say Pratha is very intelligent, she is very क्या कह सकते हैं उसको, very skillful. What she did is, she bought an iron piece and welded on this swing. और फिर उसके बाद ये और पीछे हो गई, यहां जाके बैठ गई. अब करके बताओ, ये करके दिखाओ, गाना गा रही है इस पे बैठ के, ये करके दिखाओ, ये. तो अब क्या होगा जब प्रथा बिल्कुल पीछे जाके बैठ गई? इन दिस केस व्हाट वुड हैपन इज, मयंक वुड बी अप इन द एयर एंड प्रथा वुड बी डाउन टू अर्थ, राइट? डिस्टेंस बढ़ाएंगे सेंटर से तो टोटल टॉर्क, टोटल मोमेंट ऑफ फोर्स विल इंक्रीज, और डिस्टेंस कम करेंगे तो मोमेंट ऑफ फोर्स और टॉर्क वुड डिक्रीज. इज दिस क्लियर टू एवरीवन? यस और नो? सही है? Very good. बहुत बढ़िया. That's great. Now, let's come to this question now. Right. Okay. So let's see this question and try to apply the same principle, the same formula in this question now. So this question says, figure represents a meter scale. Now, what do you mean by meter scale? एक scale जो 1 मीटर लंबा हो. A scale which is 1 meter in length. Right. That is a meter scale. So, this is a meter scale balancing on a knife edge. So this is a knife, okay? It is balanced on a knife edge at 20 centimeter mark. Where is it balanced? At 20 centimeter mark. So zahir si baat hai, if this is a meter scale, so this will be total 100 centimeter in length, right? This will be 100 centimeter long, right? Acha, ek cheez aur. Do you know about center of gravity? The basic idea of center of gravity. I think I have explained it in the second video of the chapter 4. Center of gravity, yes? So center of gravity is the point where we assume that all the mass of the body is situated at a point which is an imaginary point, and that is known as center of gravity. Right? So every element, if the element is like this, बिल्कुल straight है, तो the center of gravity would be at the center. जिस point पे इसको हम balance कर सकते हैं, वो हो जाएगा इसका center of gravity. तो इसको जिस भी point पे balance करेंगे, वो हो जाएगा इसका center of gravity. For a uniform in length material, the center of gravity will always lie at the midpoint of that, right? So if we are talking about a scale, a meter scale, then the center of gravity by default for a meter scale would lie at which point? Marking बताइए, at which marking? What would be the marking? 50. Very good. So if we place the knife at 50 centimeter, so that means this distance is also 50 centimeter and this distance is also 50 centimeter since it's a 100 centimeter scale. So the center of gravity will lie at the center of this scale. Is this okay? Is this understandable? Yes or no? Clear hai sabko? Right. So at 50 centimeter, that would be the point of equilibrium. Right. Now see, in this question, what it says is, this is a meter scale which is 100 centimeter in length. A knife, this is balanced on a knife edge at 20 centimeter. Now, by default, it should be 50 centimeter, but now we have inserted the knife at 20 centimeter. And in order to balance out this scale, what we did is, we have used two weights. One weight of 60 Newton at 10 centimeter. The other weight, we don't know the weight. Let's say it is W at 50 centimeter. Now, this scale is in the state of equilibrium. Now, if this scale is in the state of equilibrium, then that means we will apply what? Principle of moment. Principle of moment is what? Principle of moment says that the clockwise moment would be equal to the anti-clockwise moment. Yes or no? हाँ या ना, जल्दी से बताइए भाई, ये चीज क्लियर है? क्योंकि ये बैलेंस्ड है, ये इक्विलिब्रियम पे है, therefore principle of moment would take place, and according to the principle of moment, the clockwise moment will be equal to the anti-clockwise moment, right? So that means now clockwise moment का मतलब क्या हो गया? Clockwise moment का मतलब हो गया ये वाला जो है, बताइए ये clockwise है या ये anti-clockwise है? Is this clockwise or anti-clockwise? This one. This is anti-clockwise, correct. So this is ACW, anti-clockwise, and this moment is what? Clockwise, right? So the clockwise moment is equals to the anti-clockwise moment. So let's see what is the clockwise moment according to the formula, right? So the formula for clockwise moment and anti-clockwise moment is force into the perpendicular distance from the point where the object is balanced, right? So if we want to calculate the distance between the point where the weight is tied with respect to the point where the scale is balanced, so that means we have to find this distance, right? ये distance हमको निकालना है. अब ये distance कैसे निकाल सकते हैं? So 100 centimeter के scale में this would be 0, this is 10, then 20, then 50. Now if we want to calculate the distance between 20 and 50, so that means we'll subtract 50 from 20 from 50. So force कितना लग रहा है यहाँ पे? Force we don't know. We know that the weight is W. So let's say the force applied is W into the distance. Distance would be equal to what? 50 minus 20, right? 50 minus total distance from starting point to this point is 50, and the distance from here to here is 20. So बीच का distance कितना आएगा? 50 में से 20 minus कर लो, you will get the बीच का distance, right? So this is 50 minus 20, okay? Fine. Now this is equals to what? This is equals to the anti-clockwise moment. So anti-clockwise moment with the weight is 60 Newton, right? The force is 60 Newton multiplied by the distance of this point from where the weight is hung to the middle, to the point where the scale is balanced, right? So that means this distance is equals to what? 20 minus 10. Yes or no? Correct. Now can we find W? We have one variable and we have one equation. जितने वेरिएबल होते हैं उतनी इक्वेशंस होनी चाहिए सॉल्व करने के लिए. दिस गोस इन मैथ्स एंड एज वेल एज एनी मैथमेटिकल कॉन्सेप्ट जहां पे भी लगाओगे. जितने वेरिएबल हैं, द नंबर ऑफ वेरिएबल्स, एज मेनी नंबर ऑफ वेरिएबल्स, एज मेनी नंबर ऑफ इक्वेशंस यू वुड बी रिक्वायरिंग टू फाइंड आउट द वैल्यू ऑफ द वेरिएबल, राइट? सो यहाँ पे W एक वेरिएबल है, हमको एक चीज फाइंड करनी है तो एक इक्वेशन से काम हो जाता. अगर चलो सो इसको सॉल्व करते हैं. सो दिस विल बिकम W into 30 is equals to 60 into 10. So W will be equal to 60 into 10 divided by 30. 32 times is 60. 2 into 10 is 20. So the weight of the body at 50 centimeter would be equal to 20 Newton. Is this okay? Let's see the next question now. Again, very good question. Question number 8. It says on a seesaw, two children of masses 30 kg and 50 kg are sitting on one side of it at a distance of 2 meter and 2.5 meters from its middle. Very good. So let us first make the diagram. As I already told you, agar diagram bana loge, so half of the battle is won if you make the correct diagram. Now, what it says is, on a seesaw, two children of masses 30 kg and 50 kg are sitting. दो बच्चे बैठे हैं. So let's say first is sitting over here, right? And the second one, color change कर देते हैं. The second one is sitting over here. Okay? Right. Okay. Fine. So, on a seesaw, two children of masses 30 kg. So, let's say इसका mass है 30 kg and इसका mass है 50 kg. Right? Are sitting on one side of it. On one side. That means both are sitting on the same side. Okay? At a distance of 2 meter and 2.5 meters. Okay? So, from the center, this distance is 2 meter. And from the center, the distance of this orange boy is 2.5 meters. Where should a man of mass 75 kg sit? Sight nahi hai, sit hai, sit. To balance it. Now, if we want that a big man of 75 kg weight sits on the other side of the seesaw, then what should be the position of this man from the center of the seesaw? Right? So, let's say this man sits at a distance of x meters from the center of the seesaw. Right? So, according to this, according to the POM, that is principle of moment, clockwise moment will be equal to anti-clockwise moment, right? So, anti-clockwise moment agar hum log nikale yahan se, so this man is 75 kgs, okay, fine. So, 75 force multiplied by the distance, let's say distance is x, is equals to the force exerted by both of them. So let's take the case of yellow boy. So yellow boy का अगर case लेंगे, so the clockwise moment will be equal to 2 meters distance into the force 30 plus the next boy 2.5 into 50. Right? Now we have to find the value of x. Let's find the value of x. So this will become 75x is equals to 2 times 30 gives us 60. And 2.5 into 5. So 25 into 5 is 125. So this would become 125. Right? और बीच में प्लस का साइन है. Plus 125 यही आएगा भाई? Yes or no? Great. So 75x. X would be equal to, add करेंगे तो ये हो जाएगा 185 upon 75. अब इसको आप कैंसिल कर लीजिए, जो भी आंसर आएगा that would be the final answer. डिवीजन करना सबको आता है. Yes? So the answer is 2.47 meters. Fine. So calculation, I will not be teaching you division and addition and subtraction now, since you are in class 10. तो ये आपको आता होगा. So let's see what is the next question. So the next question says the beam shown in the figure is 2 meter long and has a weight of 20 Newton. Okay, so this is a beam. ये white जो आपको दिखाई दे रही है, this is a beam. So let's color this beam. This orange one is a beam. This is a beam. Beam का मतलब पता है क्या होता है? बीम का मतलब पता है क्या होता है? सरिया. अब पता है? ठीक? Right. So this is a beam, iron beam. So the beam shown in figure is 2 meters long. So the total length of the beam is 2 meter long and has a weight of 20 Newton. Great. So the weight of the beam is 20 Newtons. Perfect. It is pivoted as shown. So this is pivoted at this point, right? So let's say this point is O. So this is pivoted at point O. Great. Two forces of 20 Newton and 10 Newtons are acting on it as shown in the figure. Okay. इसको थोड़ा सा छोटा कर देते हैं. Right. Okay. So two forces of 20 Newton and 10 Newtons are acting on this beam. What force F must be applied downwards at the other end to balance the beam? Again, we have to balance the beam. We have to make the beam in the state of equilibrium, right? So in order to do this, what we have to do is, again, what we'll be doing is we'll be applying the principle of moment. So in these types of question, you will be applying principle of moment. Now see, the beam is 2 meters long, right? So if the beam is 2 meters long, then tell me what would be the center of gravity? Where would be the center of gravity? The center of gravity किस point पे होगा? 1 मीटर पे डेफिनेटली। मैंने अभी आपको बताया था सेंटर पे होता है, ये सेंटर ऑफ ग्रेविटी ऑलवेज रिजाइड्स एट द सेंटर ऑफ a object. If the object is a straight object, then the center of gravity would lie at the center, right? So the center of this beam would be at, since this beam is 2 meters long, so the center would lie at 1 meter, right? This distance is 1 meter and this distance is also 1 meter. So that means the 20 Newton weight of this beam would act at which point? At this point. Let's say this point is M. So at point M, the weight of the beam is 20 newtons. Is this clear to you, each and every one of you? Yes? सबको क्लियर है भाई ये चीज? किसी को भी कहीं डाउट हो तो बिल्कुल बेझिझक मुंह फाड़ के बोलना, ठीक है? मतलब मुंह फाड़ोगे तो हमको दिखाई नहीं देगा, टेक्स्ट से बोलना, राइट? ओके, सो दिस इज pivoted at point O. So again, the clockwise moment will be equal to the anti-clockwise moment. Now let's find out the clockwise moment. So the clockwise moment, this moment would be equal to what? This would be equal to 20 into the perpendicular distance from the center. So 20 into 0.5 plus 10 newtons into the total distance. Total distance from the center, not from M, from point O. So from point O, the distance would be equal to what? कितना distance हो जाएगा? Point O से यहां तक का distance. Let's say this point is B, this point is A. So OB distance would be equal to what? Would be equal to 1.5 meter, correct? So this will be equal to plus 10 into 1.5. This is equals to the anti-clockwise moment. The anti-clockwise moment would be equal to what? So the distance is 0.5 and the weight we don't know. We are using F as the symbol. Now we have to find the value of F. So 20 into 0.5 will become what? 10 plus 15 is equals to 0.5 into F. So F would be equal to 25 upon 0.5. So removing the decimal and applying a 0. So 50 times is 250. So the force F would be equal to 50 newtons. Is this clear to you? Each and every one of you? Yes? 30 नहीं बेटा, 50 न्यूटन. आपने ये डिस्टेंस 1 मीटर 1.5 नहीं लिया होगा, ये गलती की होगी. मैक्सिमम बच्चों ने ये 1.5 नहीं लिया होगा, आपने 1 ले लिया होगा, इसलिए गलत हो गया होगा. ठीक है? सर व्हाट अबाउट द एक्सिस का क्या मतलब है? अबाउट द एक्सिस का मतलब है द पॉइंट एट विच द ऑब्जेक्ट इज पाइवोटेड. जिस पॉइंट पे ऑब्जेक्ट पाइवोटेड है, जिस पॉइंट पे ये ऑब्जेक्ट बैलेंस हो रहा है, दिस पॉइंट, दिस इज नोन एज, तो इस वाली एक्सिस को हम लोग कहते हैं क्या? दिस वाली एक्सिस को हम लोग कहते हैं एक्सिस. ठीक है? जिस पॉइंट पे जो ऑब्जेक्ट है वो पाइवट है, जहां पे वो ऑब्जेक्ट फिक्स्ड है, उसके अलोंग जो एक्सिस होती है उसी को एक्सिस कहा जाता है. क्लियर है? चलिए, लेट्स मूव टू द नेक्स्ट क्वेश्चन नाउ. So a uniform meter scale can be balanced at the 70 centimeter mark when a mass of 0.05 kg is hung from 94 centimeter mark. Okay. So a uniform meter scale. Again, first of all, draw the diagram. So meter scale would be how long? 100 centimeter. Meter scale would be 100 centimeter long. So 100 centimeter will be the length of the meter scale. Now this is balanced at 70 centimeter mark. So let's say this is 70 centimeter mark. So this is balanced at 70 centimeter mark. Right? When a mass of 0.05 kg is hung from 94 centimeter mark. So 94 centimeter mark would be somewhat around here. Right? Let's say this point is A. So at point A, we have hung a mass of 0.05 kgs. Is this correct or not? Is this clear or not? यहां तक क्लियर है सबको? Yes. ये हमने यहां तक डायग्राम बनाया. Now what does the first part says? Draw a diagram of the arrangement. So the first part is draw the diagram. We have made the diagram. Very good. Clear है? Yes. Okay. Next, find the mass of the meter scale. Mass of the meter scale. We have to find the mass of this meter scale. Now tell me, if this is in the state of equilibrium, if this scale is in the state of equilibrium, then what do you mean by that? कोई बता सकता है? अगर ये equilibrium है तो इससे हम लोग क्या समझते हैं? ACM is equals to CM. Very good. Anti-clockwise moment would be equal to the clockwise moment. अब ये clockwise moment, अब देखो अगर आपको दिख रहा है कि भाई वेट तो सारा पॉइंट ए पे टांगा हुआ है, तो ये वाला पार्ट कैसे हवा में है, ये तो ऊपर हो जाना चाहिए. If we have tied a weight at point A, then at point B this should go up, right? If it is not going up, that means कि यहां से point B से सेंटर तक का जो वेट होगा वो अपने आप को बैलेंस कर रहा है अगेंस्ट द वेट एट पॉइंट A, right? अच्छा, since the scale is a meter scale, therefore the center of gravity would lie at which point? Can you tell me? 50 centimeter. Very good. So that means if this point is, let's say M, so this would lie at 50 centimeter. So at 50 centimeter, the center of gravity of this scale would lie at point M, which is 50 centimeters from the starting or from the end, whatever you say. Both the things are correct. Okay. So the mass of the scale, is the mass of the scale given? No, we don't know the mass of the scale. So let's say the mass of the scale, let's take the mass of the scale as M or F, whatever. M we have already used. So let's say, let the mass of the scale, let the mass of the meter scale is equals to F. Now according to POM, principle of moment, clockwise moment would be equal to the anti-clockwise moment. So anti-clockwise moment would be equal to what? Anti-clockwise moment would be equal to the mass of the scale, that is F, into the distance between the pivoted point to the point where the mass is situated, right? So the distance between these 2 points would be equal to what? This would be equal to 70 minus 50. Yes or no? Yes or no? Similarly, clockwise moment would be equal to what? So this mass is hung at which point? At 94 centimeter. Okay. So the distance of this point A from the center, this distance would be equal to what? This distance would be equal to 94 minus 70 multiplied by the downward weight, by the force that is exerted at this point, at point A. So the force exerted at point A is 0.05. So 0.05 multiplied by 94 minus 70 will give equal to force into 70 minus 50. Is this clear? So let's calculate this. So this would become 0.05 into 94 minus 70 कितना जाएगा? 24 is equals to F into 70 minus 50 is 20. So the value of F would be equal to 0.05 multiplied by 20 divided by 24 divided by 20. So point हटाया, 2 0 लगाए, 5 से कैंसिल किया, 5 400 टाइम्स, फिर 4 से कैंसिल किया, 100 टाइम्स, 4 6 are 24. So this will become 0.06 kg. 0.06 kg. ये बेसिक मैथ्स तो सबको आती है ना, पॉइंट लगाना, पॉइंट हटाना, ये सब आता है. समथिंग डिवाइडेड बाय 100, तो we'll shift the decimal left to 2 places. So 0.06 kg would be the mass of the meter scale. Clear है? 0.06 kgs. Is this question clear to you? Yes or no? Yes. So these are all very conceptual questions. Your concepts should be clear. The center of gravity wala concept should be clear. Principle of moment wala concept should be clear. Distance kaun sa lena hai, this concept should be clear. If these concepts are clear, these questions are halwa questions, chintu questions. As I say, chintu questions, these are chintu. So these are the next questions now. So question number 1 says, figure shows a uniform meter rule placed on a fulcrum at its midpoint. So this is a meter rule. Meter rule ka matlab hai again 1 meter in length. This is placed, the fulcrum is placed at the middle of this meter scale at this point O, and having a weight of 40 GF at 10 centimeter mark. Okay, so we have a weight of 40 GF at 10 centimeter mark. So we know that every object is attracted towards the earth, तो इसका जो weight होगा वो नीचे की तरफ लगेगा, right? So this is situated at 10 centimeter mark, and a weight of 20 GF is situated at 90 centimeter mark. Is the rule in equilibrium? If not, how will the rule turn? Okay, now they are asking, is this ruler, is this scale in the state of equilibrium? If yes, then it's okay. If it is not, then how will the rule turn? That means what would be the turning effect of the force? Would that be anti-clockwise or would that be clockwise? This we have to calculate. So let's find out if this is in the state of equilibrium or not. So if this is in the state of equilibrium, which principle will work out? कौन सा principle लगेगा? Moment of force, principle of moment of force, POM, right? POM. So according to the principle of moment of force, let's calculate the anti-clockwise moment and the clockwise moment, right? So let's calculate first the anti-clockwise moment. You have to write it in the full definition, anti-clockwise moment. POM वॉम ACW मत लिख के चले आना, एग्जाम में 0 मिलेगा, क्लास टीचर 0 देगा, कहेगा ये सब क्या है, POM वॉम क्या है, ये ACW क्या है, नहीं पता उनको, ठीक है, वो यस सर से नहीं पढ़े हुए हैं, वो हमसे पहले के पढ़े हुए हैं, बुढ़े हैं वो लोग. ACM, अच्छा ACM है भाई, सॉरी सॉरी शक्तिमान, ACM है, ठीक है. तो ये मत लिख के आना, लिखना पूरा पूरा. एंटी क्लॉकवाइज मोमेंट. सो एंटी क्लॉकवाइज मोमेंट वुड बी इक्वल टू व्हाट? दिस वुड बी इक्वल टू 40 into the distance of point A from the midpoint O. So the distance would be equal to what? 50 minus 10, that is equals to 40. So this is equals to 1600. Is that clear? 1600, right? Similarly, let's calculate the clockwise moment. So the clockwise moment would be equal to what? This is equals to the weight 20 GF into the distance. Distance is 90 minus 50, that is 40, and this is equals to 800. So clockwise moment is less than the anti-clockwise moment. So this would turn in which direction? This would turn in anti-clockwise direction. Since anti-clockwise moment is greater than, since ACM is greater than clockwise moment, therefore it would turn in anti-clockwise direction. Let's come to the second part. Second part says, how can be the rule be brought in equilibrium? By using an additional weight of 40 GF. Now, if we want to tie an additional weight in order to make this ruler in the state of equilibrium, then where should we tie this 40 GF weight? बताइए, 40 GF का वेट हम इसको कहां पे रख दें सो दैट ये इक्विलिब्रियम पे आ जाए. अभी तो इक्विलिब्रियम पे नहीं है. अभी क्या होगा कि यहाँ पे जो एंटी क्लॉकवाइज मोमेंट है ये ज्यादा है, क्लॉकवाइज मोमेंट कम है. सो दिस वुड टर्न इन एंटी क्लॉकवाइज डायरेक्शन. नाउ इन ऑर्डर टू बैलेंस इट, हम इस 40 GF वेट को कहां रखें बताइए? लेफ्ट साइड पे रखें कि राइट साइड पे रखें? शुड बी राइट साइड. जाहिर सी बात है भाई, सब लोगों ने सब्जी लेने गए हैं. एवरीवन हैज परचेज वेजिटेबल इन द मार्केट. तराजू देखा है सबने, जिस तरफ झुक जाता है उसी तरफ वेट रखते हैं, जिस तरफ ऊपर चला जाता है उस तरफ वेट रखते हैं, जिस तरफ ऊपर चला जाता है. सो द लाइटर साइड इज यूज्ड टू पुट द वेट, टू ऐड ऑन द वेट, सो दैट बोथ द पैनल बिकम्स इक्वल, राइट? So the same case would be here. We would be placing the 40 GF weight on right hand side. Now where do we place the 40 GF weight? We don't know. But we know that the ACM, anti-clockwise moment, should be equal to clockwise moment in order to bring this in the state of equilibrium, right? Okay, so let's say the weight is kept at a distance of x meters, x centimeter from point O, right? If the weight of 40 GF is placed at a distance of x centimeter from point O, then in this case, then in the case of equilibrium, I am just rubbing this out. So for the case of equilibrium, for equilibrium, ACM would be equal to CM. ACM is equals to what? 1600, and this is equals to CM was what? 800 plus 40 into x, right? Because the distance of this 40 GF weight is x meters, x centimeters, and the force that it is applying on this ruler is 40 GF. So force is 40 GF, distance is x, so this would be equal to 40x. Now we have to find the value of x. 800 को left side ले जाओ, so this would become 800 upon 40 is equals to x. तो इसकी value क्या आ जाएगी? 20. So x is equals to what? 20. So x is equals to 20 का मतलब क्या है? The distance from point O to the point where we have to tie this weight would be 20 centimeter. तो 20 centimeter कहाँ होगा? At point 70. So this is the point where 40 GF weight would be hung in order to make this, in order to bring this scale in the state of equilibrium. Is this clear to each and everyone? परेशानी कभी भी आए, I am always there for you. So bye bye, take care, have a nice day. Thank you so much. We will meet in the next class. Bye bye.